Hello students, in the today's lecture we will take reflex klystron. Okay, in the previous lecture we have taken a two cavity klystron, and in this lecture we will take reflex klystron. So what is need of reflex klystron? Basically, the two cavity klystron can be converted into an oscillator, but some disadvantages are associated with it. As we know, to design an oscillator, positive feedback must be provided to the input in a way to have a magnitude of a loop gain as a unity. So if we design a klystron oscillator using a two cavity klystron, then to have a change in a oscillating frequency, the resonant frequency of the two cavities is also required to be changed, thereby leading to cause difficulty in generating oscillations. Thus, to overcome the disadvantages of reflex klystron, having a single cavity was invented to have a sustained oscillations at a microwave frequencies. Operating principle: like a two cavity klystron, reflex klystron utilizes the phenomena of velocity and current modulation to produce oscillations. However, there exists variation in constructional structure and the respective application of the two. A reflex klystron consists of a single cavity that performs the action of both buncher and catcher cavity. So in two cavity klystron there are buncher and catcher cavity, but here in reflex klystron only single cavity is there. As to have oscillations, feedback is needed to be applied at the input which is provided by the oscillator. While moving electrons undergoes velocity modulation, and repeller applies repulsive forces on them. This leads to the formation of a bunch of electrons. Further, this bunching will lead to cause current modulation. So this is a constructional diagram of a reflex klystron. Observe carefully. This is a RF input. This is a electron gun assembly. In that anode is there. Then cathode, heating element. Okay. Then grid gap is as shown in this diagram. Then these are the electron beams, and this is a repeller. Generally, repeller has provided more negative voltage. So the structure consists of cathode, as previously mentioned, cathode and focusing anode that combinedly acts as an electron gun for the tube. This combinedly acts as the electron gun. The cathode emits the electron beam which is focused inside the tube by focusing anode. So this cathode emits the electrons beam which is focused inside the tube by focusing anode. Also, a positive potential is provided as an input which sets up an electric field inside the cavity. As it is a single cavity structure, the single cavity acts as a buncher and catcher cavity separately. At the time of a forward movement of an electron beam, it acts as a buncher cavity, while at the time of backward movement, it is a catcher cavity. Okay, so at time of forward movement, means electrons moving from this side to this side, uh, it acts as a buncher cavity, and when electrons repel back, it acts as a catcher cavity, means electrons are repelled back from this repeller. Repeller plate causes backward movement of the electron beam. This repeller plate causes backward movement of electrons, and generally more negative voltage is provided to the repeller. Okay, and potential at the repeller is made extremely negative in order to permit repulsion of a charges. Repulsion is necessary in order to build electrical oscillations, as output power must be fed to the input. So the velocity modulated electrons must have to travel a backward path in order to provide feedback. Thus, repeller is used as a structure of a klystron. So this repeller plays important role as previously mentioned. This cathode emits the electrons, and emitted electrons are focused with the help of electrons, means with the help of anode, and these emitted electrons passes through this gap, and when they passes they goes towards this repeller, but again repel back due to more negative potential provided to repeller. These electrons repel back and while returning journey they forms the bunches, and also when they come towards this gap they give its energy to the gap and will get the amplified output from this side. So this is a main basic principle of this reflex crystal. So this is structures of reflex crystal used in different labs or for purpose of radar. Okay, a number of applications are there. So this is another diagrammatical representation, that is a cathode emits the electrons. Okay, and emitted electrons passes through this gap, repeller repel those electrons, and these electron repel electrons again goes towards this gap and give its energy, we will get the amplified output. Okay, the efficiency is about 20 to 30%. Okay, so this is additional diagram, you can draw previous diagram. So working, the electron beam injected from the cathode is first velocity modulated. So electrons emitted first velocity modulated by the cavity gap voltage. Some of the electrons accelerated by accelerating field enter the repeller space with greater velocity and those with unchanged velocity. So there is a change in velocity. Some of the electrons accelerated by accelerating field into the repeller space with greater velocity, and some of the entered with unchanged velocity. Some of the electrons deaccelerated by the retarding field enter the repeller region with less velocity. All the electrons turn around by the repeller voltage, then pass through the cavity gap in bunches that occurs once per cycle. So in this case, some of the electrons moves with unchanged velocity, some are move with increasing in velocity, some are reflected back with unchanged velocity, means decreasing in velocity. So there is a variation in variation of electrons in a drift space is there, and variation of electrons in drift space is known as a velocity modulation. On their return journey, the bunched electrons passes through gap as previously mentioned. On the return journey, electrons passes through gap, and during the retarding phase of the alternating field and give up their kinetic energy to the electromagnetic energy here. They give its kinetic energy to the electromagnetic energy of the field in the cavity. Oscillator output energy is then taken from the cavity. The electrons are finally collected by the walls of the cavity or other ground metal parts of the tube. Okay. Next is a Applegate diagram. So in exam, explain working principle construction of a reflex crystal with the Applegate diagram. Such type of a question is asked. So this is called as Applegate diagram. So in oral exam also draw the Applegate diagram. I say question आता है, so you have to draw like a diagram. That is first we have to mention here, that is this is E means early electron, ER means reference electron, and EL means late electron. Okay, this axis represented the time, and this axis y axis we can say distance from the cavity gap. So this is a early electron which has a more positive voltage. Observe here, here for reference electrons voltage is a 0, and for late electrons voltage is a more negative voltage is there. So according to that, for this early electron beam is accelerated during this half cycle. So during this half cycle, electron beam is accelerated, means velocity increases, and for this point, for reference electron there is unchanged velocity, and for negative half cycle electron beam is deaccelerated during this half cycle, that is a decrease in velocity. So due to this variation in velocity, electrons bunch together and bunching effect occur. So one by one we'll start this explanation. That is first, initially when the electron beam is emitted by the electron gun, then the early electrons, that is EE, these electrons experience a very high positive potential. So as observed here, for positive half cycle there is a high positive potential, and due to this strong electric field gets generated inside the cavity gap, leading to cause movement of electrons towards the repeller. So for during positive half cycle it causes the increase in the velocity, okay, and leading to cause movement of electrons towards the repeller with very high velocity. Due to high velocity, electron penetrate deep into the space. Here, due to high velocity, electrons penetrate deep into the this space. Then second case is that is for the reference electron. So observe here, for reference electron, voltage gap voltage is a 0. But when externally applied potential is almost 0, that is a Vg is equal to 0. Observe here, voltage is a 0. Then electron moves with uniform velocity with which it was emitted by the gun. These electrons are generally known as reference electrons, and so in this case ER will not penetrate deeply into the repeller space and gets repelled by the repeller in a lesser time than the early electron. So observe here, this is a reference electron, and in this case there is a gap voltage is 0, therefore they move with unchanged velocity and repeller reflect those electrons, and here they require less time, okay, lesser time than the early electron. Third case is there, that is further, that is this is called as a late electron. Further, the electron that is emitted by the gun after the reference electron experientially highly negative potential at the cavity. So observe here, this is a highly negative potential here. The electron is generally known as a light electron and moves with a very low velocity inside the tube. The penetration level of the late electron into the repeller space is less. So as we observe, time is very less here. The penetration level, the late electron in the repeller space is less. The return journey time of EL is much shorter than E and ER. So this return journey of that electron is very less or much shorter than these electron, that is early electron and reference electron. So in this Applegate diagram, it is to be noted that due to deep penetration in the repeller region, EE will take more time than ER while returning towards the catcher. This change in velocity of a moving electron is known as a velocity modulation. So what is velocity modulation? Such type of question is asked. So change in velocity of a moving electron is known as velocity modulation, and due to this velocity modulation, all the electrons get punched while the returning towards the catcher cavity. Means while these electrons repel back, then return journey they forms the bunch. The late electrons EL catch up with the reference electron ER, and E means late electron catch up with reference electron and early electron to form a bunch. So in this way, bunch of electron reaches the catcher cavity. This bunching of electron leads to cause current modulation inside the tube. Therefore, at the time of returning, the bunched electrons transfer the maximum of their energy to the catcher cavity. So here in what is bunching process in reflex crystal is explained very well in this case. That is, there are three cases: early electron, then reference electron, and late electron. So these electron, that is a late electron, catch up with the reference electron and early electron and to form the bunch. And when during return journey, they gives its maximum energy to this space, and here we'll get the, as maximum energy is provided, we'll get the RF amplified output. So in this case, one term is their transit time, and it is defined as a time taken by electrons to return to the cavity gap after getting repelled by the repeller. For sustained oscillation to take place, transit time is the most important factor. Specifications: the operating frequency range generally offered is 1 to 20 GHz. It delivers output power in the range of 10 mW to 2.5 watt. The tuning range of klystron lies between 5 GHz to 2 watt to 30 GHz at 10 mW. Theoretically, the efficiency is considered as a 22.78%, while practically achieved efficiency is only 10 to 20%. So these are the technical specifications of the reflex klystron. So in difference, these technical specifications are required. So give difference between reflex klystron and two cavity klystron. Then you can mention some of the points. Then applications. As a reflex klystron are oscillators, thus find application in local oscillator receivers, radar receivers, radio receivers, also utilized as a signal source in micro generators and pump oscillators of pneumatic amplifiers, and also local oscillator as previously mentioned. So these are the applications. Means reflex klystron is used as a at a very high frequency. So conventional tubes we can't use at higher frequencies, and also disadvantages of two cavity klystrons are removed in a reflex klystron. So it is very well used in radar receivers, radio receivers, then local oscillator in micro receiver. So what are the applications of the reflex klystron? Then you can mention these applications. Then Moore curves of the reflex klystron. In sometimes exam explain Moore curves and characteristics of a reflex klystron. Then you have to mention in the experiment we have studied the Moore characteristics of the reflex klystron. So variation in repeller voltage changes output frequency. So in this type of experiment we have taken, that is we have to keep the beam voltage constant and we have to vary the repeller voltage. As we vary the repeller voltage, there is a change in the output frequency. The frequency of a resonance of output cavity decides the oscillation frequency. Also the output power can be changed by varying repeller voltage. This is called as electronic tuning of a reflex klystron. Therefore reflex klystron can be used as a voltage tuned oscillator or frequency modulated oscillator. The nature of variation of the output power and frequency with the repeller voltage for different modes are shown, and these are known as a mode curve of the reflex klystron. So observe in the next slide, these are the mode curves of the reflex klystron. This is the output power in milliwatt and also frequency in gigahertz mentioned here, and this is a repeller voltage. So according to that these mode curves are there. So in practicals we have studied that when we vary the repeller voltage, then repeller voltage increases, and also repeller means current is also increases, and some point is there current is constant, and again when we increase the voltage, the repeller voltage means repeller current, or that is current decreases. Okay, so such type of a curve, that is in experiment we can observe. Then operating characteristics. The repeller and anode voltage must be adjusted such that bunch appears exactly at any of the positive maximum voltage of a RF signal. This is necessary for reflex klystron to undergo into oscillations. Only for a certain combination of anode voltage and repeller voltage, the oscillations are developed shows the voltage characteristics or operating characteristics of the reflex klystron. The shaded portion corresponds to oscillations for suitable repeller and beam voltage combination. So these diagrams are drawn for fixed frequency. For other frequency pattern remains the same, but the positive regions of or regions are shifted because of a change values of n. So we will observe the operating characteristics. So these are the operating characteristics curves for the reflex klystron. This is a repeller voltage. We are varying the repeller voltage, and this is an anode voltage. So these are the operating characteristics of the reflex klystron. So this is important in microwave communication. That is this reflex klystron can be used as an oscillator, or and can use as a amplifier also. Okay, so explain working principle, construction, and also working with the help of Applegate diagram. In such cases we have to explain in detail all these explanation. So go through this and go through diagrammatical representation. that is constructional details and Applegate diagram explain easy. We can explain easily with the help of that diagram. Okay, so we'll stop here. Thank you.